Alright, in this video we're just going to explore some questions that relate to square root functions. Alright, we'll solve one sort of word problem and we'll do a little bit of working backwards. So we're going to, in problem number 9, we're going to write an equation given the domain and range. So we need to write the equation of a radical that has a domain of -2 to infinity, and then a range of 2 to infinity. So let's start with the domain. So imagine that you are dealing with, that's very crooked. Let me try that again. No promises. It's hard to write with an electronic pen sometimes. So there's my y-axis. Here is my x-axis. The domain goes from -2 to infinity. So that means x value starts at -2. So here I am at -2. So the domain of this graph, so I need a function that starts at -2 and goes in this direction, like that. So picture that for a minute. So I could have a graph that started here at -2 and goes like that, or it could be higher and go like that, or it could be lower, and it could even go downward. Okay, all of these graphs have a domain that goes from -2 to infinity. So as far as that goes, I just need a graph that starts at -2 and goes to the right. Now let's talk about the range. The range is from 2 to infinity. So what is that going to look like? Let me try to sort of start over here. So I know it's got to go from -2 to the right. But now the range, it has to start at +2. So here's 1, 2. So it has to start here and go up. So the range has to start here and go up. Okay? Everything's deleting itself on me today. I don't know why. But the range has to start here and go up. So as far as the range goes, it could start here and go up like this. Or it could start here and go up. Or it could start here and go up. Okay? All three of these graphs that just disappeared start at 2 and go to infinity. So of course we need the one graph that does both of these at the same time. We need one that starts for the domain, it has to start at -2 and go to the right. But for the range, it has to start at +2 and go up. So hopefully you can see if I put those two together, if I start here, alright, I'm starting at an x value of -2 and a y value of 2. So if I start here, and in both cases I need to go towards positive infinity. That's to the right and up. So if I go like this, that's going to satisfy both criteria. Alright, this arrow that I just drew, this half of a parabola, is going to have a domain of -2 to infinity and a range of +2 to infinity. So what kind of graph will do that? Let's see. So if I have f of x equals, now compared to the parent function, this graph is shifted to the left 2. So what would that look like? Left-right motion happens when I add or subtract under the radical. Okay, so I want this to go to the left 2. So it's sort of backwards from what you would normally think, but I actually need a +2 under the radical if I want it to start off left 2 like this. And then I want it to also be up 2. Well, that is going to be a +2 on the outside of the function. That's what gives me the up 2 part. So this would be a function that would look like this and satisfy the domain and range. So this is your best bet. Now, let's go ahead and solve this word problem. Alright, the function f of x equals 2.9 radical x plus 20.1 models the median height, f of x, in inches of boys who are x months old. Alright, so this equation will give us the height of boys where x is their age in months, which is usually how we talk about babies. Okay, so inches and months. So maybe we're talking about babies and little toddlers, little kids. Anyway, describe how the graph can be obtained using transformations of the parent function y equals x squared. Well, I see two transformations here. The plus 20.1 on the end means we have one transformation, that is, it's going to be up 20.1. Now we're talking about inches, okay, in terms of the function is height. So it's going to be up 20.1 inches compared to the parent function. And then this 2.9 in front, this a value, since this number is bigger than 1, that represents a vertical stretch by a factor of 2.9. So I'm just going to write that down. Okay, so that's almost 3. So each value is going to be almost 3 times as high as the corresponding value of the parent function. Anyway, according to the model, what is the median height of boys who are 48 months? In other words, 4 years old. All right, but this equation is in months, so we're going to use 48. So what is the median height? So basically they're just saying if we know that x is 48, then what do you get? So according to this, we are going to have 2.9 times the square root of 48 plus 20.1. Okay, now so let's do two things. I have been trying as hard as I can to avoid using the graphing calculator. Well, to avoid using a calculator at all. So to answer this question, I am going to touch this calculator, but after a brief moment of weakness, I am going to pretend that this is a 4-function calculator. So if you have a quiz where or a test where you're not allowed to use a scientific calculator, I will show you how you could still do it with a 4-function calculator, which you will surely be allowed to use. So I'm just going to substitute this all in. Okay, so alright, so I've got 2.9 times square root of 48. So that'd be like this. 2.9 square root of 48, and then plus 20.1. So plus 20.1. Boom. So I am coming up with 40.2. I'll just round it to 40.2 inches. Okay. Now imagine that we could not use our TI-30XS multi-view, and instead we had only a 4-function calculator. Well, I say 4-function calculator, but even a basic calculator has a square root button on it. So we could take the square root of 48 very easily. So my strategy is going to be to start by taking the square root of 48, and then I'm going to multiply by the 2.9, and then I'm going to add the 20.1. Okay, so here I go. I'm going to take the square root of 48, which I could do on a basic calculator. Okay, it wouldn't give me that. It would give me this decimal. Now I'm going to multiply that by the 2.9. So I've got this in the calculator, so I'm just going to go times 2.9 and hit enter. So now I've got this. And so I've took the square root, I multiplied by 2.9. Now I'm going to add 20.1. So I'm going to go plus 20.1. And as you can see, I get the exact same thing I got before, 40.19 blah blah blah, or 40.2. So you could do this with the basic calculator that you would be allowed to use on a test or quiz, even when we don't have our precious TI-30XS multi-view. Let's see, can we answer the next question without touching the TI-30? We'll see. Use the model to find the average rate of change in inches per month between birth and 10 months. Okay, round to the nearest tenth. Well, that's what we were doing. This is the nearest tenth. Now, when they say rate of change is just a slope. Okay, so all we have to do when they start talking about rate of change is to make a little chart. So we're doing x's and y's. Okay, so they said between birth and 10 months. So remember, the x value is our month. So birth, that's 0 months, and then 10 months. So those are our x values. So let's talk about the y value. So if I let x be 0, right? If I substitute in 0 right here, then that would be 2.9 times the square root of 0 plus 20.1. Now, of course, square root of 0 is 0. 2.9 times 0 is 0. So basically, this goes away. And at birth, we are looking at the 20.1 inches. Okay? According to this model. Now, at 10 months, so now we're talking about substituting 10 in here. So I can almost just do it without rewriting it by going like this. Boom! I'm so clever. So 10 at 10 months. So even with a basic calculator, I could take the square root of 10, multiply by 2.9, add 20.1. So let's pretend this was a 4-function calculator, or a basic calculator. I could take the square root of 10. Boom! It would give us a decimal though. And then I would multiply by 2.9. So times 2.9, enter. And then add the 20.1. So plus 20.1. Boom! That is 29.3. Got to round up. Alright, so these are the two values that we have. Now, the average rate of change is the slope. Alright, so the ROC, the rate of change, is just a slope. Alright, it's y minus y over x minus x. So the slope, I'm doing y minus y. So 29.3 minus 20.1. Okay, you know what? I should sort of show the formula. Alright, the rate of change is just the slope. And slope is y2 minus y1 over x2 minus x1. So that's all we're doing is calculating the slope whenever they say rate of change. So y2 minus y1. So that's 29.3 minus 20.1 over x2 minus x1. So that's 10 minus 0. Okay? So that is going to be, so 29.3 minus 20.1 is 9.2. Okay, and of course 10 minus 0 is 10. Well, 9.2 divided by 10 is 0.92. Basically move that decimal point 1 point to the left in order to divide. Alright, so to the nearest tenth, that's 1 decimal place. So that's going to be 0.9 inches. It's rate of change. So I can't just say inches. It's going to be something per something. So in the top, the y values, those are inches. But these x values are months. That's month. So so I almost made a mistake when I said 0.9 inches, like it was just a height. This is a rate, so it's inches per month. So 0.9 inches per month. Everything's disappearing on me. 0.9 inches per month. That is the average rate of change. Okay, any other questions we can tackle? Use the model to find the average rate of change in inches per month. Oh, okay, it says it right there in the problem. I feel silly. Between 50 and 60 months. How does this compare to our answer in part C? Okay, so basically we're going to see, are we growing faster or slower? All right, 0.9 inches per month. That's almost an inch a month. Okay, that's pretty fast growth. All right, can you imagine if right now you grew an inch a month? Okay, so that you'd be growing a foot in a year. All right, we don't grow that fast anymore like we did when we were little babies. So let's see if the growth rate slows down as we get to the 50 to 60 month range here. So again, let us do our table of values one more time. Okay, a rate of change. So we need our table of values to do this. So 50 and 60 months. So there's 50 and 60 months. Okay, I've showed you how to calculate this by hand, like with a 4-function calculator, but that's getting tiresome. So I'm going to cheat and use the table feature, but you know, I showed it to you a couple of times how you could just multiply, take the square root, multiply, add. So feel free to do that, but that's getting old. So 2.9 times the square root 48. Why did I put 48 right there? It's supposed to be x. And then plus 20.1. All right, do I have that right? All right, 48 was for that particular problem. That's why it was in my head. But the formula in general, 2.9 square root of x, 20.1. Okay, so using this in our table function, and I am going to use ask mode, so I can just cut to the chase and ask it whatever I want. Ready to go. So at 50 months, oh wise calculator, how many inches? That is 40.6 inches. Okay, 40.6. What about at 60? 42.6. Still got to round up. 42.6. So let's find the average rate of change. The average rate of change is just going to be the slope. Okay, so ROC, rate of change, is just going to be the slope. Okay, and we know the slope is y2 minus y1 over x2 minus x1. And we are talking inches per per month. So let's see what we've got here. So y2 minus y1. So we're talking about 42.6 minus 40.6 over x2 minus x1. So that's 60 minus 50. Okay, well, this is just 2, all right? 42.6 minus 40.6, that's just straight 2 inches. And 60 minus 50, that is 10. Now 2 divided by 10, again, move that decimal point one time, that is 0.2 inches per month. Okay, how does this compare with our answer to in part C? Well, just as we suspected, for the tiny babies from birth to 10 months, all right, less than a year old, they are growing on average very quickly, almost an inch a month, 0.9 inches. But by the time they are between 50 and 60 months old, their rate of growth has slowed down from 0.9 inches a month to just 0.2. All right, that is a fifth of an inch a month instead of almost a full inch a month. It's just a fifth of an inch each month, which is still growing a lot faster than you or I. So how does this compare? 0.2 inches per month is a much slower rate than 0.9 inches per month. Okay, there it is.